here tonight's presentation, not only because Andras is incredibly colourful to my totally black outfit, but also because architecture has been a persistent topic of conversation over the past couple of years, and the discussion around architecture has really just increased over the past couple of years. It's been a very hot topic. So I'm very excited to have our main presentation this evening. We all give a big round of applause. What do you finish it,
Cool, thanks everyone. Screensaver's good. I've got 53 really quick slides, so don't worry too much. Let's just start the timer. Cool, so basically a little bit about clean architecture, which has been around for a while, but people don't talk about it too much. It's not new, it's like 20, 30, 40 years old as a concept, but this is more about how to apply it to day-to-day Android projects as this example, but it can be used with any technologies. And at the end there's some bonus stuff with Kotlin. So next, cool. That's all the stuff. So a little bit about me, a little bit of history of clean architecture, high-level concepts and concerns, a process for implementing it in real life, and yeah, nerd stuff. So who am I? I work for this company, DS. I think we're a bronze sponsor for DevFest, so that's kind of exciting. I've been working professionally for like 12 years, so I've got a bit of experience. I used to do mobile games, and that was like 5.5 years, so now I've been working at DS for about 6.5 years. So I've done a lot of different kinds of background things, so different kinds of apps and different kinds of programming styles lead to different kinds of architectures that work better for them or not. I do a heap of other stuff as well. I'll make these slides available at the end, not for this stuff so much, but for all of the links and things that are in the rest of the presentation. So, very brief history of clean architecture. Who hasn't heard of Uncle Bob? Like half the people, that's cool. He's like an evangelical programming guy. He's been around forever as well. Not literally forever, but a while. So basically he's the main evangelist for clean architecture, I think. It's kind of his baby, but even he doesn't claim to have created all of the concepts. So yeah, it's got a lot of history. There's a fun video in here if you want to watch it. It goes for about an hour and it's just like him yelling the whole time. But his first blog post about it is from only 6 years ago. But the concepts are like since the 70s in Objective-C and event and messaging based protocols. So you can find out more about it from that if you want. It kind of exploded a bit more into web frameworks, but even that's like a while ago. And they don't all follow it strictly or implement it very well or easy to reason about or anything, so there's a lot of varied history, not just here's the right way and everyone's like, oh, this works perfectly. So why should you care about this kind of architectural style? Basically, it's got a bunch of really good reasoning benefits. So if you don't lay out your code in a nice way that helps you understand what's going on without a debugger, it can be really hard to work out what the bugs are. You shouldn't need a debugger to be able to tell you what your program is doing. Like, you wrote it, you should know what it's doing just by looking at it. But one of the main thing about clean architecture is a similar concept to one of the main things about functional programming, which is you want to move side effects outside of your core logic to well-defined boundaries. So if you're working with code that doesn't know about side effects, then you should be able to reason about it all the time because it doesn't do anything unexpected. So that's probably the main takeaway from this. As a general tool and approach, it's not perfect for everything, but I think as an approach it's good for almost everything to some extent. Like if you've got a really, literally, genuinely trivial app that does basically nothing, like a to-do list, this is probably overkill. But almost no real apps are that simple. When you start off, if you try and do this from the start, especially without much experience with it, it'll seem like you're just writing a lot of boilerplate code. But as you grow your app bigger, that boilerplate becomes actually really useful. So what situations are actually really well suited? I guess the best, most ideal situation is if you're making an enterprise app that's got a lot of stuff in it, that's got a lot of people working on it. You want to be able to build it quickly with lots of people all working on stuff at the same time and not make a lot of merge conflicts. If it does complex things, hopefully not complicated, but complex, like you need to coordinate some things. If you've got an API and on-device storage and in-memory cache, you want to coordinate those without exposing all of those different layers to the UI or to the backend. And there's a bonus that if you do have a lot of people, or even if you're just working on your own, because this is separated into several layers, you can make small branches, so small PRs, that are self-contained, that don't need much context to understand what's going on. If you don't do this, it's not just if you don't use clean architecture, but if you don't follow those kind of guidelines, you'll end up with programs that are hard to reason about. It's hard to tell what's going on because they either have side effects, or they do too much stuff, or they have copy-pasted code between different layers. And if you fix a bug in one spot, you might not fix it in another because it's not dry. Yeah, basically all of that. If you start doing things like keeping state in volatile places, like in the UI or in the DOM, you'll have troubles. Like if your activity gets recreated because you changed orientation, but you were keeping some load-bearing data in there, like what does your app do? Who knows? So the concepts. Basically, if you did computer science and or software engineering in uni, you have at least heard of these, but not everyone did CS at uni. So really quickly, the solid stuff is really good for OO, but really good for everything else as well. So single responsibility is one of the biggest ones for clean architecture, and dependency inversion. So things should depend on abstractions, not concretions. So we define interfaces for connecting the layers together, and then something provides a concrete interface, a concrete implementation. And maybe that's provided by DI, or maybe you do your own dependency injection or whatever. Independent of frameworks, UI, databases, and external agency is really important for this. So one of the goals of this is to have the core of the app just in plain platform-specific language. So it's in Kotlin, or it's in Java, or whatever your programming language is. It doesn't have any frameworks in the core. All the places where the business logic is plain whatever, plain old Java, plain old Kotlin, whatever. So you can run unit tests on it. The layers are segregated well, so you don't need to mock and stub a lot of things. You don't need to talk to Android. You don't need to run stuff as instrumented tests or as roboelectric tests or something, because you don't need the Android runtime to run the unit tests for your core logic. Cool. So extra helpful stuff. Yeah, some of these build off of the solid ideas, but some of them are kind of a little bit separate. So separation of concerns is a really big one. If you take this architectural style very literally, you'll end up with lots of tiny classes that only do one thing. So the concerns are very separated, but you'll end up with lots of tiny files. Some people don't like that, but it makes it very easy to reason about because they're not making things complicated. Encapsulation and composition, because you've got lots of tiny things that only do one thing, they're really easy to combine and still reason about. Dangerous practices, you don't want to optimize or abstract things too early. This kind of gives you a base level of abstraction that's a reasonably good fit for almost everything because it provides the layers and the intent of the layers. The layers that I'll present soon, you don't have to have these like exact 3 or 5 layers. You can build whatever layers make the most sense for your app, but this is kind of a minimum set. So some of this stuff I'll come back to right at the end, but helpful related constructs like type-safe containers. We just saw some stuff about RxJava, and that's using kind of an observable pattern. Basically, those are just containers that map between different types and pass along a chain all the way up to your UI or the other way around, depending on what you're doing. There's a lot of stuff you can take from functional programming that helps separate how it works from what it does. Pure functions are really helpful for reasoning because they don't have any state and they don't modify any state. So if you take a function as a mathematical function, whatever its inputs are deterministically determine what its outputs are. And then a heap of Kotlin stuff that I'll do at the end as well. So the layers. This is a totally exciting bit. There's basically 3 kind of layers that I kind of touched on before. So there's the core, which is in plain old whatever language you've got. There's a presentation layer, which for Android is like activities and fragments and views. And a data layer at the other side, which is could be any kind of framework or platform-specific API usage. But for Android stuff, you might have like network client, an API client that's like retrofit or OKCDP or something, or even Android-specific platform APIs like encryption or on-device persistence. But the core doesn't need to know about that. It just says, I want to save something. And somewhere later you say, here's an object that you can use to save things. The final one is this cross-cutting concern, which is, like logging or something, you need to sprinkle it somewhere, everywhere, but you want it to be the same everywhere. So configuration provides all the concretions that all of these abstract dependencies need. So the core doesn't know what's going to be calling it. It doesn't have to. The core doesn't know what implementation of persistence it's going to use, but configuration provides that for you. I've got 3 diagrams. This one is the one that I like the least because it's really hard to tell what's going on at the start. But basically there's a line on this side and a line on the bottom side. So the stuff that's inside those 2 lines is the core here. The stuff that's on this side is the presentation layer, and the stuff that's on the bottom is the data layer. This has some really good concepts, but because it's a little bit hard to read, I'm not going to go into it on this slide. But one of the interesting, important things is there's this interactor guy over here. So there's a inbound interactor and an outbound interactor, and that's going to become important for some of my examples later. This is a way more popular diagram, but it also doesn't tell you how to implement this. So it's got a few concepts that should be familiar if you've done RX stuff or React or anything like that. So there's a data dependency order. The stuff on the inside doesn't know about the stuff on the outside. It just presents interfaces so the stuff on the outside can hook in to the inside. So core entities don't know anything about how they're going to be used. It just says this is all the stuff that you can do. The use cases don't know what's going to use them, but they talk directly to the core, etc. Down here starts hinting at how the program execution order works, but this next one is way more exciting because it's the same diagram, but it's got a squiggly line that says this is the things that happen in order. So say you've got a UI, you like hit a button or you type in a form or something, it comes in through whatever thing it talks to in this layer. So maybe it's an event handler. The event handler talks to a use case that says, hey, you clicked the button and this is the kind of action that I want to do when I click the button. Say it's like pulled out a view model from here, it's converted into a domain object, and say you want to like send it to an API. So you go out through a gateway and then that talks to the API and you get a response. It comes all the way back through the chain of things that it talked to on the way in and ends up making some change back in the UI. So all of that is basically stateless. It just passes through a pipeline of steps down to one end, and then the responses come back through the pipeline. So that's the really high-level quick version of what the layers are for. So here's a bit of code. Very exciting, only one line of code per slide. So there's a little bit of dense information up here. There's a dependency thing up the top, so the use cases know how to talk to stuff in the entity layer. This is the core. The data layer knows how to hook itself into the entities, but the entity layer doesn't know about the outside ones. So the dependency order is in. So starting from the top end of the core, so this is all just plain colon, it doesn't know about Android or anything. We've got a use case. Say this is the banking app that I just released, and we can see an account list. So after you've logged in, you can see what accounts you've got. The use case says, I don't need any information, and I'll give you an account list. But this is a list of summaries because like the list might be long and I don't want to give you too much detail. I'll say I've got a response container type here. So what we're actually doing here is not like RX. We just do one call, we get that one value, we don't ever update it. But I'll touch on that a bit more later as well. Next layer. So there's an entity manager class on the next layer in the entities layer. It knows how accounts work. If you want to get an account list, it's like, sure, I'll give you an account list with all of the details. And then the use case is going to transform that to the summary version because the app doesn't need that all the information. Importantly, this guy knows how to manage its own data sources. So the thing that holds the domain knowledge knows if it has a cache or not. It knows if it needs to talk to an API or not, and it manages the staleness of those. But the use case doesn't need to know that. This does the magic for you. The next layer down, which is the bottom edge of the core, is just presenting an interface for something in the data layer to hook into. So it says, when I want to show an account list, I'm going to call whoever is registered in this output, in this inlet. So if you provide me some credentials, or if I provide you some credentials, you'll give me back a list of accounts from the API. And say we've also got some persistence, so it's doing some on-device storage. The last one is talking to like a retrofit API client. say. This one will just be talking to shared preferences or something where you would store some data on the device. It basically does the same thing, except it doesn't need credentials because it's on the device. So that's literally the core. It's just like the core logic and then two public interfaces, one for incoming stuff and one for outgoing stuff. On the top end, if the top is the user closest end, there's some UI stuff. So you're going to want your activities and fragments and stuff to be able to talk to the use cases. So say you're using data binding, you've got a view, it's got a view model. You want to be able to push a new view model to the view so that your data comes up on the screen. So you've got a presenter that knows about your data binding. When it gets a response, it just converts it and pushes it to the view. Should be pretty simple. I did explain this slightly before, but I'll keep going. So we get way more code per slide now. On Slack, pretty recently, in the last week or two, some people were talking about why you wouldn't need Dagger. And this is basically why, because all the magic it does is pretty easy to do yourself. So I've just got this configuration singleton that's cut in half by the screens, but that just provides the dependency graph. It only initializes all of this stuff the first time you ask for it because you don't need it before then, but that's fine. It's lazy and it just creates some data classes basically. So this is all of the layers that I just talked about. And it just wires together the bits in the layers that we know need to talk to each other. So if I've got an API client, the only thing that it needs to know is which URL to point at. So it doesn't have any of these other layer dependencies. But the next thing that needs to talk to the API client does. So the account list provider gets a Lambda that knows how to do the work. And it just keeps going up that way. Because we're working with Android, for this example, we're not in control of the activity and fragment lifecycles. So you have exactly the same issue that you would have with Dagger, where in your fragment or your activity, you need to get your dependencies injected. So we can't wire anything up above the use case layer because we're not in control of its lifecycle. But the fragments can just grab stuff out of this graph. Yeah, that's basically it. I don't know if you feel any more enlightened. It's probably still a little bit too abstract, so I'll keep going with some other more interesting stuff. Yeah, so I did talk really quickly about that was just using a response object, so you just get back one value and you never change it. What do you think you'd do if you wanted to change it to observables? So say we've got this response object. I'm pretty sure you just change this to like observable and everything keeps working. Maybe you just publish one piece of data and then the app works exactly the same. But if you wanted to, you could keep updating stuff because these are type-safe containers, they just keep working. So maybe that's not so exciting. I really quickly said like the account list is only gives you back summaries because you don't want too much detail on that. If you wanted to like tap on one of those accounts to go to a detail screen, then you'd end up with a different thing that instead of giving you a list of accounts, you get a single details. So you can do that easily. How am I going for time? Because I stopped my timer by accident.
5 minutes.
5 minutes? Great. Some other stuff that I worked on that also used basically clean architecture ideas. It's not that exciting, but if you go and look at these links, you can get some example code, or I mean, you can't get the code for the VR app, but you can play with it if you want. This is basically an open source app for people wanting to play around with a small idea that's more complex than a to-do list. And it's got React Native examples, Spring Boot and Kotlin, I think Android and Kotlin, and regular React, all building the same thing with kind of the same layers. And more nerdy stuff, so I hope you like programming. So the core is all Kotlin, like I said, so it's really easy to unit test. Because everything's decoupled, it doesn't actually depend on any concrete things. You can just provide those in your tests, and that really just gives you the stub data. You might have noticed there was almost no logic. Every layer just does a little thing. So there's basically no business logic except in the entity layer. Everything else is just wiring together bits of pipeline. Same with the API client, that's just a retrofit thing. It's got a connector, so it's taking domain classes, turning them into HTTP requests. You get an HTTP response, it turns that JSON back into a domain class, and then you can test that separately with contract tests. So you don't need an Android runtime for that. You can just run that in plain Kotlin. All of the container classes that I've got in this app, I just wrote because they're very small. So like I've got a response type that can be either a success if you got back like a 200 range HTTP status, a failure if you got back a response but it's not in that range, or an error if something else went wrong, like you didn't have network connectivity. And I've got basically the same thing for form validation. So I've got type-safe form validation for every field. You can say whether it's successful or not, and then you can flat map all of those together to give you a view model. That's how that works. It's not a lot of code, but it does some nice things. It's basically stealing some ideas from Scala, but you don't get, there's one bit of sugar that you don't get from Scala, which is for comprehensions. So for each layer that takes a response, we basically want to map it from one type to a different type, and this map provides that. So if I've got a response of some JSON type and I want to turn it into a domain type, I just provide the map function. If it succeeded, then it converts it. If it didn't, then you get the error. So the flat map always collapses to error if you got an error. Otherwise, it'll do all of the success transforms. Same thing for validation, but it's a bit simpler. That's what one of the validators looks like. So it's, once again, it only does a tiny little thing. It just checks if it's within the right character length range, gives you back an error if it isn't. Otherwise, it gives you a success and gives you back the value from the field. More sugar, so for every request that I want to do that needs credentials, you just run it through this. So if you've got credentials, it runs the function. If you don't, you get back an error. And that's how you use it. So no state. We've got immutable types. Everything's just data classes with vals, no vars. So you take an input, converts it to an output. That's deterministic. It doesn't even really need a unit test because it doesn't do anything. Extension functions, because you could have a lot of copy-pasted stuff for handling on-done in fields if you didn't add something like this. And I don't want this like thing copy-pasted in a bunch of different fragments. So you just say on-done, you give it a tiny little lambda, and then it does the same thing everywhere. Hopefully people have either done that already or see how easy it could be to use. Same thing for classes that already exist that are part of the platform. So you can add things to strings, you can add things to byte arrays, so that it cleans up your code. A little bit of stuff about data binding, but I think Max is going to have to talk about that sometime soon. But this just sets up some generic stuff so that it automatically binds and gives you back the binding as a member variable. And then you end up with tiny, tiny little fragments that don't do much. I'm sensing a theme here. That's all I got. There was a lot in there.
So I think we've got time for maybe 2 or 3